In this lesson, we will examine some features of quadrilaterals. To begin, a quadrilateral is a polygon with four sides. The first property about quadrilaterals is that their angles add to be 360 degrees. Now there are five types of quadrilaterals you must become familiar with: the square, the rectangle, the parallelogram, the trapezoid, and the rhombus. Let's begin with the parallelogram. One of the most important features of a parallelogram is that its opposite sides are parallel. In other words, it has two pairs of parallel sides. Also in parallelograms, the opposite angles are equal, and the opposite sides have equal length. Now, a special type of parallelogram is a rectangle. A rectangle is a type of parallelogram because its opposite sides are parallel, its opposite sides have the same length, and the opposite angles are equal. In fact, the opposite angles are not only equal, but every angle is equal to 90 degrees. So a rectangle is a type of parallelogram that happens to have four equal angles of 90 degrees each. Now another type of parallelogram is a rhombus. A rhombus is a type of parallelogram because its opposite sides are parallel, its opposite angles are equal, and its opposite sides have the same length. In fact, the opposite sides are not only equal, but every side is equal. So a rhombus is a type of parallelogram that happens to have four equal sides. Finally, a square is another type of parallelogram since its opposite sides are parallel. A square is also a type of rectangle since it has four equal angles of 90 degrees each, and a square is a type of rhombus because it has four equal sides. Okay, the last quadrilateral you should know about is the trapezoid. Now a trapezoid is not a type of parallelogram since it does not have two pairs of parallel sides. However, a trapezoid does have one pair of parallel sides. So if a quadrilateral has two parallel sides, then it is a trapezoid. Now there are two additional properties I should mention at this time. The first property concerns the rhombus. And since a square is a type of rhombus, the property concerns squares as well. The property is that the diagonals of rhombuses and squares are perpendicular bisectors. So if we add a blue diagonal here and then a purple diagonal, the two diagonals will intersect at 90 degrees. Furthermore, the purple diagonal will cut the blue diagonal into two equal pieces, and the blue diagonal will cut the purple diagonal into two equal pieces. The second property concerns rectangles, and since a square is a type of rectangle, the property concerns squares as well. The property is that the diagonals of rectangles and squares always have equal length. So these two diagonals must have equal length. Okay, our last topic concerning quadrilaterals will be how to find the areas of these five shapes. Now, although we have five different shapes here, their areas can be found the same way. That is, the area will always equal the base times the height. Now, the way in which we find the base and the height may vary with some shapes, but the one formula holds true for all of them. Now, for squares and rectangles, it's pretty straightforward. The base will be one side, and since the angles are all 90 degrees, the height will be the length of a side that is perpendicular to the base. For parallelograms and rhombuses, the process is slightly different. Now the base can be any side. However, the height will be the perpendicular length from the opposite side to the base. Now once we know the base and the height, we simply multiply them together to find the area. Finally, to find the area of a trapezoid, we will still multiply the base times the height. Now finding the height is no problem. It will be the distance between the two parallel sides. However, it appears that either one of the parallel sides could be the base here. So which one do we use? The answer is both. If we call one side base 1 and the other side base 2, then the formula for the area of a trapezoid will be base 1 plus base 2 divided by 2 times the height. Now let's take a close look at this part. Notice that finding the sum of the two bases and dividing by 2 is the same as finding the average of the two bases. So the formula for finding the area of a trapezoid is just a special version of base times height. Now before we end this lesson, I'd like to make one last point about finding the area of a rhombus. Now we have already seen that we can find this area by multiplying the base times the height. However, another way to find the area of a rhombus is to multiply the lengths of the two diagonals and then divide by 2. Let's look at an example of this. Let's say that one diagonal has length 4 and the other diagonal has length 7. So the area will be 4 times 7 divided by 2, which equals 28 over 2, which equals 14. So this rhombus has area 14. Okay, to summarize. In this lesson, we learned that the 4 angles in a quadrilateral add to 360 degrees. We learned some properties of 5 types of quadrilateral. And we learned that we can use one formula to find the area of all 5 shapes.